Okay, so we've been introduced to the molecular shapes with, you know, linear and trigonal planar, and then this is tetrahedral, if you remember right. But I wanted to do a specific video about the hybridization, and that's the one with the S and the P. And particularly, we're going to talk about hybridization with regard to carbon because 9 times out of 10, when you're being asked about hybridization, they're asking, for the hybridization around a carbon atom. Now, this hybridization will work for other atoms too, but what I'm saying is you have to be really keyed in when you're dealing with carbon. They're going to ask you about the hybridization around that carbon atom. Now, the most common hybridization for carbon is sp3, okay? And just consider that as one S, 3 Ps, 4 things. So sp3 is carbon attached to 4 things in a tetrahedron. It is 109.5. This is really the most common form carbon has. It's when, now this could be in a big chain, and you could have carbon, carbon, and then 2 hydrogen and whatever. But as long as that carbon that you're looking at is attached to 1, 2, 3, 4 things, that's an sp3 hybridized carbon. Okay, our next one is sp2, and this one has the trigonal planar. Now, this is a carbon atom right here in the middle, and you can see that that carbon has made a double bond with, like, usually it's oxygen or something like that. It could be sulfur, or it could be, honestly, another carbon that's also sp2. But this is the carbon we're dealing with right here, and it is bonded to 1, 2, 3 things, S, 2 Ps, 3 things total, 1, 2, 3, sp2. Bond angle, 120 degrees, okay? The other way you can look at these is if you can figure out the angle, and if the angle of this carbon is 109.5, any carbon you look at that has a 109.5 angle is going to be sp3. Any carbon you look at that has a 120 angle, that's going to be sp2. Now, sp is going to be a little different here. So, I got to take apart here. I know this is scintillating video. And then hook this back up. And I will show you. Now, it can be okay. Now, I'm missing one piece for this structure, so, don't sue me. I'm missing that little guy right there. So, this is the most common linear structure for carbon, and this is carbon dioxide. So if you look, it's got a double bond to one oxygen and a double bond to the other oxygen. Okay? So that's one way that carbon can be an sp. And you'll notice that these are all kind of in a straight line just because of the way we had to build it. It's, not like straight line, but, we could look at it like that as well. That's normally how we would draw it. And so you can see that linearity there. And so anytime you have carbon and it has an angle of 180 degrees between the things it's attached to, or anytime you have carbon and it's only attached to 2 other things, that's going to be sp, okay? So it can either have 2 double bonds or a triple and a single, okay? So anytime you have carbon and that angle around that carbon is 180 degrees because it's only attached to 2 things, sp. 2 things, sp, 180 degrees, linear structure. So that is the hybridization of carbon.